Today we are going to see about load test on series motor. So this is the panel that we should connect accordingly to the circuit diagram. And this is the 2-point starter to start the series motor, and 2-point starter only should be used for the starting the series motor, and 3-point starter for the DC shunt motor. And you can see this is the nameplate details of DC series motor, and also this is the DC series motor with loading arrangement. You can see make is Benlack, and power of the motor is 5 HP, voltage 220 volt, current rating is 19 amps, so you can give the load up to 19 amps, and speed is 1500 rpm. This is the average, that is the average speed we have given, but the series motor we should start only with the load. The apparatus stickers are DC ammeter 0 to 20 amps, because we are having only 19 amps motor rating, and voltage is 0 to 250 volt DC voltmeter, and connecting wires. See load test on DC series motor, and the aim is to find the performance characteristics of DC series motor by conducting the load test. You can see the apparatus required here, given here: DC series motor setup or number, voltmeter, ammeter and tachometer, connecting wire and fuse. And this is the formula used: torque equal to S into 9.81 into R Nm, and input power equal to VL into IL watts, output power equal to 2 pi NT by 60 watts, and efficiency output power by input power into 100%, where S equal to load, R is radius of breakdown, VL equals line voltage, IL equal to line current, N equal to speed in RPM, T equal to torque in Nm. And this is the circuit diagram. You can see we should give the connection according to the circuit diagram. See now, according to the circuit diagram, from plus we are giving to the positive of the ammeter, and from the negative of the ammeter we are giving to the positive of the voltmeter, and from the negative of the voltmeter we are giving to the negative of the supply, DC supply. See, and from positive to the positive of the voltmeter, and from negative you are giving negative of the supply. You can see from minus of the ammeter and plus of the voltmeter we are giving to the 2-point starter L. From 2-point starter A to field of the, that is series field, A to series field. And from series field to motor A, and from AA to minus of the supply, and from series field to motor. And from motor to the voltmeter minus or see from the motor to voltmeter minus or to the minus of the supply DC supply, but we are giving to the minus of the DC supply. Now you can see the series motor is started with load, and you can see S1 and S2. S1 is 0 and S2 is 10, and you can see the amps is 10 amps and the voltage is 180. Increase the load. You can increase the load. So see, you are increasing the load and you are getting 12 amps and the voltage is 180 and the speed is 1570. Speed is 1570. Speed is 1570. 1570. Amps is 12 and amps is 12. 180 and spring balance is 0 12 and the spring balance is 0 12. Okay, 0 12 and speed. Okay, you are going to increase the load. See, you are increasing load by using the and the amps is 14 amps and the voltage is 180 and the speed is, you can see the speed by using the tachometer. 1512. Next you are going to increase the load. Increasing load. You can see it is 16 amps. You can see the amps is 16 amps and the voltage is 180 and the speed is 1446. Speed is 1446 and this is 16 and this is 180 and the spring balance is 1 and 2 and 14. 2 and 15. Okay, next reading you can take for 18. Okay, we are only taking 4 readings and you can see this is the tabulation column. This is the tabulation column. You can see VL, IL, spring balance reading and spring balance difference, speed in RPM, torque, input power, output power and efficiency. Already we have seen the formulas how to use according to the tables, that is according to the readings we have taken. Using the formula you can solve and the efficiency can be noted down. And this is the model graph you have to draw. You can see the efficiency, percent, torque, speed and output power. And I will give you a link for the full calculations and observation work in this video. You can see in the description the full link. Thank you.